This is Earth, our home, a green oasis in the vast cosmos. But if one day this oasis is no longer safe, where will we go? Is there a Earth 2.0 inches out there? A world with a breathable atmosphere, with boundless oceans? But what conditions are truly essential for a planet to become humanity's new home? Join us as we investigate the most viable candidates, and in particular, reveal the defining factor, the ultimate secret for distinguishing a real Earth 2.0. The one thing you can only discover by watching to the very end. Let's begin. Before we begin, support Beyond Earth by liking and subscribing. Thanks for exploring the universe with us. Today, we're going to explore a few potential candidates for colonization, hoping for new discoveries. In the long run, if human civilization wants to survive, we must find a new home. Based on this, we recently hoped to colonize and live on Mars. However, colonizing Mars could lead to terrifying mutations, perhaps even the extinction of humanity. Mars has a thin atmosphere, allowing cosmic rays and solar radiation to reach its surface continuously. Even if astronauts wear spacesuits, the moment they step onto the Martian surface, they will still be exposed to intense radiation. In addition, the radioactive dust on Mars' surface poses a major threat to us. These dust particles are extremely fine. They can even penetrate sealed cabins. The first colonists will also face bone and muscle deterioration. Future Martians may completely lose the ability to move without an exoskeleton. Not only that, but their internal organs may also degenerate, even turning into a gelatinous state. If researchers claim that Mars is completely unsuitable for life, then where else can we escape to? Scientists are searching for planets that could serve as an alternative home for humanity. Not just any ordinary planet, it's a super Earth. It turns out that, among all possible worlds, Earth is not the best. For most of its existence, Earth was uninhabitable. The reason lies in plate tectonics and changes in the sun's brightness, fluctuating between blazing heat and freezing cold. So what conditions should an ideal planet have? Researchers believe that an ideal planet should have about twice the mass of Earth. Its average temperature should be around 25 degrees Celsius. Additionally, the planet should have a thicker and denser atmosphere to protect against radiation and other harmful factors. Until recently, scientists were unable to study exoplanets in detail from a distance. However, with the advent of the James Webb Space Telescope, they can now capture images of these planets. This breakthrough has allowed scientists to study celestial bodies that were previously only theorized. The most reliable way to obtain accurate information is to send astronauts on field missions. NASA has developed a spacecraft capable of instantly transporting humans into space, reaching distant exoplanets. A scientific research team has been assembled to begin the search for new worlds. However, we must carefully select our exploration targets. Otherwise, we may repeat past mistakes with certain stars. For example, the celestial body once known as Fomalhaut. The planet is located 25 light-years from Earth. Fomalhaut b was initially identified as an exoplanet by NASA's Hubble Space Telescope in 2004. Early observations depicted it as a bright, cold spot moving rapidly across the sky. However, further investigation revealed that there was likely no planet there at all. In fact, scientists now speculate that it may never have been a planet at all. This debate has been ongoing since 2004. Astronomers observed several celestial objects in 2006. In fact, these may have been the result of a collision between two celestial bodies, forming a huge icy cloud. With computer models, the researchers concluded that the dust cloud may have formed from the collision of two icy objects, each about 200 kilometers in diameter. Hubble mistook this cloud for an exoplanet. This means that even the most advanced telescopes and satellites can provide data and photos that mislead us. But what happens if such an error is discovered too late? Tens of thousands of Earth's inhabitants boarded spaceships, only to find themselves trapped in space with no hope of return. Fortunately, the misunderstanding was quickly resolved, averting a potentially catastrophic expedition. And so, the expedition to find a new Earth is about to begin, with HD 189733b as the astronauts' first hopeful destination. From a distance, this planet seems promising, with an atmosphere and plenty of water, much like Earth. However, as the spacecraft drew closer, the true nature of HD 189733b began to emerge, shattering all initial hopes. This place is simply uninhabitable for humans. If we were to land here, we would be forever trapped in this deceptive hell. That seemingly abundant water in the distance, it's nothing but shards of glass. The atmosphere of HD 189733b is rich in silicate particles. Silicates melt and cool into glass shards due to extreme heat. Adding to the danger, the planet is ravaged by violent storms reaching speeds of up to 8,700 kilometers. But even if the astronauts could survive these extreme conditions on this deceptively calm blue planet, they would face another terrifying surprise, a surface temperature soaring to 834 degrees Celsius. The expedition would have been instantly incinerated by the heat. Fortunately, they discovered HD 189733b's true nature in time. The search for a new Earth continues. Next, let's turn our attention to TRAPPIST-1b. Discovered in 2016, it was initially classified as a super-Earth. TRAPPIST-1b has a diameter approximately 1.5 times that of Earth. According to initial data, the conditions on TRAPPIST-1b seemed suitable for life. And astrophysicist Thomas Green of NASA's Space Research Center for Science and Astrobiology firmly believed that the planet possessed a thick atmosphere. The thick atmosphere could protect the surface from overheating. Yet, even if we assume the data available to the astronauts is completely accurate and confirms that TRAPPIST-1b is indeed a viable exoplanet for human survival, despite the initial promise, they may still face the risk of landing on a giant fireball. This is because the climate of TRAPPIST-1b could change dramatically during their journey. TRAPPIST-1b is incredibly close to its star, only 1% of the Earth-Sun distance. Although its star is much fainter than our Sun, TRAPPIST-1b still receives 4 times as much stellar light as Earth does. And according to the latest data from the James Webb Space Telescope, TRAPPIST-1b's surface temperature can reach 230 degrees Celsius during the day. If our astronauts were to land on TRAPPIST-1b, they would face a gauntlet of unpredictable dangers. Is there a planet that meets all our criteria? Don't despair, we may have finally found it. Kepler-22b. The first exoplanet discovered was initially promising, but later calculations revealed it's far less habitable than we thought. In 2011, the Kepler Space Telescope discovered Kepler-22b using the transit method, which detects planets by observing dips in a star's brightness. This meant a planet was orbiting the star, dimming its light and allowing scientists to detect it. So what do we know about Kepler-22b today? Kepler-22b is a massive world, 36 times the mass of Earth, with a radius 2.5 times larger. Surprisingly, this planet is considered potentially habitable, sharing some familiar characteristics with Earth. A year on Kepler-22b lasts approximately 290 Earth days. Kepler-22b's orbit is actually 15% closer to its star than Earth is to the Sun. If Earth were that close, we would be instantly scorched. But Kepler-22b has one crucial advantage. It orbits a star that is smaller and cooler than our Sun. This means that, despite its closer orbit, Kepler-22b receives roughly the same amount of sunlight as Earth. Based on these factors, scientists estimate that the surface temperature of Kepler-22b fluctuates between a comfortable 15 and 22 degrees Celsius. So is it time for our astronauts to pack their bags and set course for Kepler-22b? However, this planet may still hold some hidden meanings and unexpected surprises. When scientists simulated the rotation axis and orbital period of Kepler-22b, they discovered that the planet is tilted. This could be quite dangerous, because at this tilt, one side of the planet will always face the star, enduring unimaginable heat, while the other side remains in total darkness. When a planet orbits a star, it is constantly changing position. To survive, we would need to continuously move around the planet to stay within the habitable zone. Therefore, the colonists would need to design science fiction like walking cities, or build a mobile space colony, allowing people to migrate easily to suitable living areas. But we shouldn't ignore the planet entirely. New research shows that Kepler-22b may be entirely covered by a single layer of water, with oceans up to 50 meters deep. This water layer may play a natural role in climate regulation, helping balance extreme temperature changes. Now let's talk about gravitational forces. If Kepler-22b is twice the size of Earth, then its gravitational pull may be several times stronger. This means that on this planet, gravity will be significantly stronger, increasing our weight. Sudden changes in gravity are bound to cause joint pain and blood pressure problems. However, evolution may help us adapt to these conditions. Over time, colonists on Kepler-22b may become shorter and lighter. Ultimately, our species may evolve into dwarf-like creatures less than half a meter tall. On Kepler-22b, everything will change, even the arrangement, structure, and size of our internal organs. For example, our hearts might become larger. To function more effectively in a high-gravity environment, blood may become less dense, and some organs might even disappear. This would help allocate resources to more vital physiological functions instead of less essential ones, like the appendix. But it's not just humans who would need to evolve rapidly. Animals on Earth might need to develop extra limbs to better distribute their weight. Despite this, the challenge goes beyond that. Our astronauts on Kepler-22b's surface can't find stable ground to land on. NASA scientists speculate that Kepler-22b may not be a suitable planet for development. Some researchers claim that it may be more like a gas giant with a solid core. If the first settlers discovered that they were on such a planet, they would have to find a way to build a floating city in its orbit. Therefore, our home on Kepler-22b would likely resemble a dense cluster of bubbles floating in the upper atmosphere. However, surviving on these super-Earths would be a challenge for the toughest. This is why our astronauts will continue searching for more suitable planets to inhabit. But what if such a planet doesn't exist? During our expedition, we may discover that not all exoplanets are hospitable. This means we will have to adapt to new conditions in order to survive. We might even have to mutate. As we continue exploring new worlds, what will the future of humanity look like? Certainly, it depends entirely on the planet we choose. We must be extremely careful. Appearance alone is not enough to judge a planet's suitability. For example, if I look through a window and see a beautiful scene in my field of vision, a planet like J1407b, I shouldn't go there immediately. It is known as the ringed superstar of Saturn. This name comes from its massive ring system, which is about 640 times the size of Saturn's rings. However, the planet itself is composed of enormous green gas clouds formed by turbulent rivers and seas. With no solid surface, it is constantly accompanied by violent storms. We'd better not get too close. It's not just a gas giant, it's another extreme world like J1407b, where it often rains diamonds. Although diamonds may sound alluring, let's explore other exoplanets first. Next, let's take a look at VHS-1256b. It was first observed in Chile and was only discovered in 2015. Observations of VHS-1256b suggest that it may also be a gas giant. However, researchers have noticed that this planet has an unusual red color, suggesting that some kind of dust may be present in its atmosphere. This means that on VHS 1256b, there might be something resembling solid ground. But even if we are unlucky and descend deep into its atmosphere, we may still find no solid surface. The gas here gradually becomes denser until it eventually transitions into liquid at the planet's core. At the heart of the planet, there may be an ocean, not of oil and water, but a vast sea of liquid hydrocarbons. So how can we survive in such an environment? First, we need to understand that the pressure here will be unimaginable. Under these conditions, we would have to evolve into deep-sea-like creatures with natural protection against radiation. As for our living environment, we would need a specialized platform to remain afloat in the dense clouds of VHS 1256b. The building itself should be a single-story structure because under extreme gravity and pressure, people would move very slowly. If humans decide to settle on VHS 1256b, we may end up as sluggish, turtle-like creatures living in spherical houses. Now that's not an attractive prospect, is it? Let's continue searching for a more habitable planet, like Colonize b. In 2009, the planet was discovered, becoming the first exoplanet of its kind found by humans. Scientists believe that, during its evolution, it may have been 100 times the size of Earth. However, as it moved closer to its star, the planet heated up and lost its atmosphere until only its core remained. The main issue is that Colonize b orbits its star at a constant distance, 60 times closer than Earth is to the Sun. During the daytime, the planet's temperature can reach up to 2,593 degrees Celsius, hot enough to melt and vaporize rocks. Therefore, not only can you find boiling oceans and lava here, but you might also encounter stone-like fish, formed due to the tidal locking effect on the planet's surface. Colonized regions of this planet always face the star. The other side remains in extreme cold, with temperatures dropping as low as -235 degrees Celsius. It seems that the only habitable area on this planet is the narrow zone between its two hemispheres. This area is very small. It's not large enough to support humanity. With limited space and resources for survival, we will either have to fight for these zones or adapt to extreme environments. First, we will face the problem of low gravity. Low gravity will cause our muscles and bones to weaken and the spaces between our vertebrae to widen. As a result, humans may become taller with elongated limbs and a curved spine due to lack of use. In addition, if we talk about the hot side of Colonize b, our flesh and bones would not be able to withstand such extreme temperatures. But titanium can. Through evolution, humans might develop titanium-like skin. As for housing in this environment, an underground bunker would be the ideal choice, built near the border of the cold side, close to ice sheets for water. Surviving on the cold side of this planet might be easier. To keep warm and prevent frostbite in our limbs, we would need a thick layer of fur. For shelter, we can take inspiration from igloos designed by indigenous people on Earth. These structures not only resist the cold, but also protect against cosmic radiation. Since this area never receives sunlight, the interior of our shelters would require powerful artificial light sources. But that's not enough. A smart heating system is also essential to prevent the ice structures from melting. Therefore, no matter which planet humans choose to inhabit, one thing is inevitable: we must adapt our way of life and even our appearance. But if this is true, then the process of evolutionary regulation has already begun. Scientists claim that humans, as a species, may have already reached a turning point in our transformation. In 2004, a research team at the University of Pennsylvania announced the discovery of a gene called MYH16. This gene has caused the human jaw to gradually shrink, and some people are now even born without wisdom teeth. Additionally, certain human bones are gradually turning into cartilage, making the skeletal structure more flexible. In theory, this could help us adapt to gravitational forces different from those on Earth. So which planet would you be most fascinated by? Thank you for watching. Don't forget to like, share, and subscribe for more space adventures.